Have you ever tried to draw a perfect circle and it just ends up looking like a wobbly potato? Yeah, me too. But what if I told you that with a couple of really simple tools, you could create these flawless shapes, not because of some amazing artistic skill, but because of pure logic? Well, today we're diving right into the simple magic of geometric constructions. You know the feeling, right? You've got this perfect picture in your head, maybe a house or a person, whatever it is, but when you try to get it down on paper, it just comes out, well, a little wobbly. The lines aren't quite straight, the curves are kind of lumpy. It can be so frustrating. So the big question is, how do we fix that? How do we turn that shaky, uncertain sketch into a figure that has crisp, confident, perfect lines? Is it really just a matter of practicing for hours and hours until our hands are perfectly steady? No, not at all. And that's the cool part. The answer isn't about becoming a better artist in the way you might think. It's about using a totally different kind of intelligence. The secret, it turns out, is in a simple set of tools and a powerful system of rules we call geometry. Okay, so let's start with our first magical tool, the compass. It might look pretty basic, but it's actually an incredible little piece of engineering that's designed to enforce one perfect, unbreakable rule. And that one rule, it's the very definition of a circle. See, a circle isn't just a round shape. It's technically a collection of all the points that are the exact same distance away from a single center point. This idea of equal distance, that's the key to all of its perfection. And this is where the magic really happens. When you set the width of the compass, you're defining that distance, the radius. When you press that sharp point into the paper, you're setting the center. And then, as you sweep the pencil around, the compass is physically forcing every single point it draws to obey that rule. It's not really drawing it all. It's executing a perfect mathematical command. Okay, so we've totally mastered the perfect curve. But what about straight lines? Let's take a look at how these same ideas, these rules, apply when we start building things like squares and rectangles. The rules for these shapes are actually surprisingly simple. You've got a rectangle, which has two main properties. Its opposite sides are equal, and all of its corners are perfect 90-degree right angles. Then you have the square, which is even stricter. For a square, all sides have to be equal, and yep, all corners have to be 90 degrees. So when you think about it, a square is really just a special, more disciplined kind of rectangle. So knowing the rules is one thing, but how do we actually make them happen on paper? How can we use our tools to construct a perfect square with, let's say, 6-centimeter sides? We do it step by logical step. First, you draw your 6-centimeter base. Then you construct a perpendicular line, which is just a fancy way of saying a line at a perfect 90-degree angle, to make sure that first corner is flawless. Now here's the really clever part. You use the compass, set to 6 centimeters, to measure up that new line. That guarantees your second side is the perfect length. You just repeat this process, letting the tools and the rules guide you to a flawless square. There's zero guesswork involved. All right, so we can make perfect circles, we can make perfect squares. Now, this is where it gets really fun. Once you understand these basic rules, you can start combining them to create things that are way more complex, moving from simple blueprints into what looks like genuine art. So let's take on a challenge from our source material, building this little house figure. The rule is simple. Every single borderline has to be exactly 5 centimeters long. Now the base is easy, no problem. But the roof, that's a puzzle. That top corner, point A, has to be exactly 5 centimeters from point B and 5 centimeters from point C. How in the world do you find that one perfect spot? Seriously, think about it. How would you find that one single, precise point in space? I mean, you could try to eyeball it with a ruler, kind of moving it back and forth, but you'd just be guessing. There has to be a more elegant, more precise way, right? And here it is. This is that big aha moment. We use our trusty compass, we set it to 5 centimeters, and starting from corner B, we draw a light arc. We know point A has to live somewhere on that curve. Then we do the exact same thing from corner C. And the crucial part, the single spot where those two arcs cross is the only point on the entire page that is exactly 5 centimeters from B and 5 centimeters from C at the same time. It's such a perfect, elegant solution. You know, this power, this ability to find a precise point based on its relationship to other points, is such a fundamental concept in geometry. And once you really get it, you start to see that these simple techniques are the hidden engine behind some incredibly complex and beautiful designs all around us, from architecture to modern art. Just take a look at this. This pattern looks so intricate, so beautiful, right? But you're not going to believe how simple it is to make. It is just a perfect square, and then you place the point of your compass on each corner, one by one, and draw an arc. That is it. 4 simple, identical steps create this gorgeous, symmetrical piece of art. How cool is that? This whole idea of planning ahead really highlights a key piece of wisdom from our source material. The magic isn't in just jumping right into the final drawing. The real power is in the plan. A quick rough sketch helps you think through the rules and the steps you're going to need to take before you ever pick up your compass. It's like a game plan. So, really, what we've seen today is this amazing journey from the chaos of a wobbly, uncertain line to the order and beauty of a perfect geometric world. Geometry isn't just about shapes in a textbook, it's like a hidden language that lets us describe and create our world with absolute precision. And that leaves me with a final thought for you. Now that you know a little bit of the language, the simple rules of lines and angles and arcs, start looking for it. From the buildings you walk past to the design of the logos you see every day, what other hidden geometry